Good day. Hello everybody. Today the live session of reinforced concrete road bridges, and we shall discuss on hello. Good day. Hello everybody. Today we shall discuss in the live session of reinforced concrete road bridges, and what I could say before you ask all questions, and let me give you that reinforced concrete road bridges that we are having working stress method and limit state method. For the limit state method, this is the same thing which we are going to use it for several times, but it is appropriate to inform you that one. So, let us come back. Mainly that is true for reinforced concrete structures, and then we shall come back our IRC. This one I am talking from IS 456. So, and mainly we are talking for flexure. And so, if we can see, and there will be certain assumptions that plane sections normal to the axis remain plane after bending. The maximum strain in concrete at the outermost compression fiber is taken as 0.0035. The tensile strength of the concrete is ignored. The stress block may be assumed to be rectangle, trapezoidal, parabola or any other shape which results in prediction of strength in substantial agreement with the results of test. The stresses in the reinforcement are derived from representative stress strain curve for the type of steel used. So, for steel we shall have different values. For design purposes, the partial safety factor GM equal to 1.15 shall be applied for steel. The maximum strain in the tension reinforcement in the section at failure shall not be less than Fy by 1.15 ES plus 0.002. That means, for steel it varies, the value it varies, but for concrete it is always 0.0035. So, just to give you idea the reinforced concrete how it works. So, you can see, because this way I have made it to just show that you can see the sequence instead of giving the whole thing at a time that I have given. So, as you can see that epsilon SU which will be equal to on the basis of your say that grade of steel. Then you are having parabolic rectangular part, the C, and then T, and then 0.45 FCK, then K2x. So, is the distance of the center of compression in the concrete from the top compression fiber, and determination of constants of K1 and K2, that is our interest for compression stress block. So, obviously, we shall draw the figure 0.45 FCK. This portion, that is say due to first of all the point at the middle, this is actually your say 0.002 and this is 0.0035. So, 0.002 means this portion will be 4 by 7, as you can see 4 by 7 equal to 0.57 x, and 3 by 7 means 0.43 x, and this is the force C, and this portion is K2x. For working stress method, it is 1/3 of x, that means K2 equal to 0.333, but here K2 will be different because of the rectangular and parabolic distribution of stress. So, you can find out this portion we have to remove. So, this portion we have to remove, and if that be the case, that is the parabolic portion, then C equal to area of rectangle minus area of outer parabola. So, this is the outer parabola, and which equal to 0.45 FCK x b minus 0.45 FCK 0.57 x by 3 b. So, 0.45 FCK x b minus 0.086, that means, if you take that one, you will get it 0.086 FCK x b. So, which equal to 0.364 FCK x b. So, this is the value we shall get it, that means, C equal to 0.364 FCK x b, and therefore, K 1 equal to 0.364. Sometimes we write down 0.6, and depending on the value however you truncating it, on the basis of this K 1 value also can come as 0.361, but anyway we can say 0.36 if you really would like to go. Then what about the value K 2? So, 0.364 FCK x b we have got it. Now, taking moment about neutral axis is this one at the bottom. So, 0.364 FCK x b minus x K 2 x, that means, this portion K 2 x and this portion something, that means, x minus K 2 x, and that is what we have done, will be equal to 0.45 FCK x b into x by 2 minus 0.45 FCK into 0.57 x square into b by 12. So, this is the value we shall get it. So, simplifying it, 1 minus K 2 0.584. So, K 2 equal to 0.416 or equal to 0.42, and so we can find out K 2 and K 2 we can find out. So, C equal to K 1 FCK x by d into B d, T equal to 0.87 Fy AST, and compression C equal to K 1 FCK x by d into B d, and tension T equal to 0.87 Fy, Fy by 1.15 is nothing but 0.87 Fy into area of steel. So, equilibrium equation 0.87 Fy AST equal to 0.364 FCK Bx cube. So, let us find out the limiting values of x by d. So, type of steel, Fy yield strain xu by d. So, mild steel 250 0.0031 0.53 xu by d. Then high yield strength and high yield strength another one. So, one is 415, another one is 500, and you get this value 0.48 0.0038. So, 500 0.0042 and 0.46. So, I think balance sections, that is known anyway, just to give you idea. So, sections in which the tension steel reaches yield strain simultaneously as the concrete reaches the failure strain in bending are called balance section. And then obviously, when you are talking balanced value equal, then we should be have less than. So, sections in which tension steel reaches yield strain at loads lower than the load at which concrete reaches failure strains are called under reinforced. And over reinforced sections, the sections in which the failure strain in concrete is reached earlier than the yield strain of steel is reached are called over reinforced section. So, this one actually I would like to tell you because this is the thing that what we have learned. Now, what I would like to show, so we know so we are getting this value k 2 x and then this is t, and obviously we can find out m, say u, any one of them will do. So, m equal to C z or T z. Now, what we do, if this is your neutral axis, then what we should do, if it is a neutral axis, then we go for IRC 112. For that case, what we do, this is the strain that we know, and the corresponding stress we consider something like this. So, this one is x. So, we get here so, if we get this value f, so even if we take it rectangle, so will be equal to so we can find out here and so since I have written here 0.45, so I shall give something lambda, where lambda equal to 0.8, so that 0.45 into 0.8 and so we get something 0.36, and here also we get it the same value. That means, we do not change the force, rather we change the only gap, the rectangular part equivalent area we calculate multiplied by the force 0.45 FCK will give me the shape bending moment whatever we have got it earlier, and that way it is very easy to do. This is the one IRC, Indian Road Congress, they have done. So, in Indian Road Congress they have done for this case we do it. So, our objective here, that instead of going for rectangular parabolic one, we go for rectangular with certain adjustment, and that lambda equal to how much? This lambda whatever we have written here. So, that is equal to 0.8. So, that way we can adjust, that means 0.36 we shall keep it same, only thing making the little less, so that I can get a equivalent rectangle, and which will be easy to calculate also. Okay. There is one question here, how to decide the column orientation in a structure. This one.
No, sir. So for next page, you can just click on this icon.
Okay, okay. So what we shall do it here, as one question is there that I have seen, that how to decide the column dimension. So this is a building plan So, this is a building plan. Now, question is, there are columns, let us give some other one. Let us say this is one type of column and this is another type of no, some other color let us give. So, this way. So, that is little bigger. So, the column is here that A and then B, that orientation different rectangular column. If it is circular, no problem. If it is square, also no problem, because whatever orientation you give, no problem. Now, the question is for the red one, let us say so, is it the first one? Let us give it 1 or 2. Similarly, we can go for it can be like this also. So, considering the present situation, since we are talking this one as A and this one say B. So, if we do like this, then this is not acceptable, and obviously that we can make it, but the B is this one. So, B whatever we can do it here, B also this type of thing is not acceptable, only acceptable this one and this one, because whenever you are taking moment, say for example, x and y, take moment of different columns. So, then what we shall do with this orientation, that orientation will be A, then only with respect to x y, the moment of resistance will be more, because here the width is very less, but here width is very more. So, we always provide in this particular fashion, we always provide the column dimension. So, there is no such question here, and then what I can do actually, that regarding exam purpose, then I can say something. We generally keep that one 25 questions, 20 questions recall type we call it, that means we did not actually spend much time for computation other things also, and then remaining that you can say 10 questions, sorry, here you are having 10 questions. So, remaining 10 questions you are having 2 marks. So, 10 marks, 10 into 2, 20 marks, and then you are having another 5 questions of 4 marks each. So, generally for question number set 1, the 10 questions, 1 or 1, that one you can say 2 marks, that we can give, 1 mark also you give, 1 mark, then for the other one we give 2 marks, and then final one that we give actually 4 marks each. So, this is the general situation, that how we put it your say that questions for the exam purpose. There are few questions are there. What will be the paper pattern that I have told, and no code, nothing will be allowed. No code, nothing will be allowed here in this case. Whatever things required, that you will get it. Please make more videos on substructure design. Yes, I should make it by this time. Will it be offering it again next? Yes, we offer generally the one we offer in that autumn semester we offer. So, obviously, we shall offer again in the next autumn semester we shall offer. This time it is little late, but we shall offer again next. So, since there is no other question, I shall just simply go back with something that will be helpful. This is a part of bridge engineering course, and so I have many more slides. And limited method, the reinforced concrete structures, what is the topic today, and IRC 112. So, I am not going to detail up all those things, this is the same thing. So, we shall come back to limit state of collapse, that is flexure, and as you can see that parabolic rectangular diagram, which is generally used in IS 456, and here we use it alpha. There is one parameter alpha, we make it here, and that alpha, first one, that one we are having 2/3. Next we divide by 1.5, and in that way it comes 0.45. So, this is the formula generally they give in Eurocode, little bit more with explanation. So, sigma c equal to FCD 1 minus epsilon c by the same thing, whatever we have written there, the same thing, only that we have written the equation of the parabola. So, for our case it will be n equal to 2, we make it quadratic, then 0.002 up to certain level and 0.0035 up to certain level. It can be bilinear also, and here you see whatever we have done. That means, this is the one, that compressive one, if we have a concrete with the higher strength. So, x epsilon cu 3 x, and here we are making lambda x. So, instead of getting the same parabolic and rectangular one, we make everything parabolic, so that we can reduce that one, and final one will be your lambda x. That is 0.2 x will be reduction, so that I can utilize that one with respect to rectangular, that your say rectangular block, that we can do. Instead of having that say parabola, then your say rectangular, instead of that we go for that rectangular, which is very easy to do it. So, this is the thing, whatever you have told earlier, the same thing we do it. So, here that this is the basic concept of 112. For that we apply limit state method. However, we can use working stress method also. Let us see any other question is there or not. Okay, Santosh Kumar Chandoli, in non-earthquake zones, for high rise buildings, should we earthquake design for that structure? So, Generally we do it because non-earthquake means actually what we can say non-earthquake. We generally do not tell in that fashion. Whatever way we should have certain Richter value, we have to decide on the basis of that whether there is a possibility in future, that is not possible to know. So, on that case we just simply whatever value that your zone, for that case we can design. And one more information I would like to show you, already possibly you have got it. I thought I shall already, I think I have circulated that impact factor, working stress method, all those things there. So, this is the impact factor for that 4.5 by 6 plus L. Then tracked vehicle 25% for spans up to 5 meter linearly reducing to 10% for spans up to 9 meter, for wheeled vehicles 25% that we generally do. So, impact percentage, so we can for spans less than 9 meter, the value of the impact percentage shall be taken as follows. For tracked vehicles 25% for spans up to 5 meter linearly reducing to 10% for spans up to 9 meter, for wheeled vehicles 25%. For spans of 9 meter or more, the value of the impact factor shall be taken as follows. So, we get it from IRC 6. These values already we have given actually. And the curve of impact factor, it comes in this fashion: 15.4% for spans of 45 meter or more, 8.8% for spans of 45 meter or more. So, the actually I have given that one, say working load allowable stress method, whatever the values that we get it. Actually I would like to make it like this, that our working stress method, the stress is like this. The limit state method, for limit state method rectangular and parabolic. And this is limit state IS 456. And then we have so, whenever we are talking here, so this area which is equal to 0.364, so this value whatever we are getting it here, and this value F, so we shall get this force or C that we shall make equal, our objective equal, but for the time being we can sacrifice that your say certain portion of the neutral axis portion, because in this case you are talking 0.416. In this case we are talking 0.45, but it will be x by 2. So, this is the simplicity what we do in IRC 112. Okay. There are a few more questions. Avinash Karmakar sir, if NPTEL can organize a courses where we can learn different types of analysis software, that will be very helpful for us. Yes, that is true. Actually, here why don't you try with that your own language, say Python you can try, because nowadays I work with Python, that you can try on your own. What should be the minimum grade of concrete used in bridge load? Actually, we are having substructures and then we are having superstructures. So, let me come back. We can go M25, M35, and here we can go M35 onwards. So, we can make a different kind of thing that we can do it, just wait. So, whatever you are talking, this particular one, say different types of analysis of minimum grade M25 or something for the you can say, or M30 also for substructure, and then superstructures little higher. Yeah, I do not know what you are talking. Please explain the load calculation on a column as well as on footing. Load calculation on a column as well as footing. I think you are possibly this is on reinforced concrete road bridges. So, mainly we cover on beams, actually superstructures. Anyway, whenever you are talking that one, say on columns. So, columns means actually that are you talking for analysis or something that generally, but whatever, if you I do not understand that when will the hall tickets issued, that I also do not know for the time being. I shall find out. What is the question of Avinash Karmakar? Okay, but in the meantime, let me tell you something about the column and NTP. I do not know what you are trying to say, it is not clear to me. So, for a building are you talking, or okay, there are two things. One is that say abutment. Whenever you are talking abutment, this is the plan and we are having say bearing. So, under this whatever load will come from the superstructure, and then that load and the self weight of the abutment will give you that load on the column. Almost you can say that one as a column, and on the basis of that you can find out how much load is coming. You can take 1 meter width also you can take, or you can take the full width also you can take. Now, if you say that for a building, so thumb rule that without going for any calculation, lateral load, all those things. So, I can say so, this is the one that area which will come under this column, and that way you can find out that if you do not go for analysis, rigorous analysis. So, roughly you can calculate and it will give you idea what will be the that how much load actually is coming there, that way you can find out. Okay. Can you tell me what meta count? Oh, what is NTPL? I do not know whether you have from is it that one that when I am giving lecture from there you have did I say NPTEL? I do not know what I have told, but NTPL I do not know what do you mean to say. Mira Kaur, can you explain this? What I do not know, I do not get what is it. So, are exams going to conduct online from home or exam center? It is supposed to be exam center, I think. Can we prefer working stress method? Yes, this is a good question. Yes, you can use it as a working stress method also. Okay, fine. Okay, so thank you, Avinash. I think you have that one possibly I understood. Maybe from my pronunciation, possibly he has misunderstood that one as a new term. Shubhamay Desh, your lecture is very helpful. I have improved myself a lot watching your lecture. I want to see more and more lectures from you. Okay, I am also very much interested, but somehow other I could not make it. But if you like, you can try, or somebody is telling actually, since we are having some time, I could say what is my idea. You just learn one language, and I prefer I am using say language Python, and that one I am using extensively from 2009. Since 2009 I am using, and almost you can say hobby, you can say addiction also, because every day if I do not write something, and then what happen actually, then it is a somehow other I do not feel comfortable. So, I have to write something, whatever it is, all those things, and so that way, and try to do something. There are many more things are there available nowadays in YouTube also. From there also you can get idea. If you know my email address, you can mail me also. I can also, I have a small video, I make it and I send it also, I make it. Why slab is not designed for, slab is designed for bending moment only, because slab, you see, slab is a thin structure, thin section. So, that is why you consider for bending moment only, you can say, and beam actually you consider say bending moment as well as shear force. How do we design different types of abutments and foundations? Okay, though the time is very less, okay, just to give you idea, just different abutment types, just quickly, we do not have that much of time. So, as you can see, for different kind of abutment, you can find out, this is the bridge abutment, you can find out here, and then this is one, and based on the height, we can find out that how much will be the value. This is another type, closed end monolithic, closed and short term stem, short stem, this is called stem, short stem type abutment. I am just going to measure thing. So, dead load of superstructure, dead load of wall and footing, dead load of earth on heel of wall including surcharge, dead load of earth on toe of wall, earth pressure on rear of wall including surcharge, live load on superstructure and temperature and shrinkage. So, these are the different design load it comes. This way we can take this one also, this is one type of case. This is another type of case we can take it. This is third case, all loads are considered. So, dead load superstructure, wall and footings for different cases actually you can take it. So, allowable pile capacity of allowable soil pressure in percentage of basic 100, case 3 means there are case 3, temperature and shrinkage. So, 150, similarly case 4, all loads are considered. So, 125 and then case 5 will govern only when dead load reaction falls ahead of center of gravity of piles. So, then it is 150. So, we consider for seismic design for different kind of things we consider and we calculate the values, and there is certain kind of thing what the abutment drainage other things also we do it. But what I mean to depending on the type of abutment whatever and we govern it, we break up into either design for bending, design for column or axial load, design for torsion, design for shear, then we find out the torsion, axial load for beam other things we just simply modify, we calculate that value. So, there are certain kind of things actually we know that we can make it, we are having the time very short. So, for different abutments other things we just take the values that one is the sliding, another one that that toppling. So, like that or say what is called your say bearing also, that whether that particular area where that you are going to construct, whether the column that soil can take that load or not. Actually, my plan to make that abutment foundations also one such course, or in a combination it will be a part of that. So, Pankaj Sharma I think as for bending in moment, I think that one it is I have already answered. Okay, so that one again yes, I have already told I think possibly that regarding that column position all those things. So, that orientation depending on that it comes. So, if you can say that one say here this is like this, depending on that whether it will be like this or it will be like this. So, the column here that is the one you can say column, just say my mobile that cross section of the column, the top of that. Now, depending on that of the column position it that where maximum bending moment that you would say bending moment say for example, the size is less or no. Yes. So, this side it is a shorter side, so if it is shorter side, so it is very easy to bend like this, and then that direction that shorter side one you just provide the that column orientation. Where we can learn manual analysis you learn from your basic load and say for example, abutment, whenever you are going for abutment. So, apply the basic load that you say whatever load is coming from the, let us say very simple one. Simple one I can say just we have few minutes only. Let us say this is a beam, this side also another one, you are having that PR. What simple way you can do that we are having dead load we are having a live load. So, dead load and live load, one way you can do it, we can take it half of it there. If you think that okay, it can come little more, so we shall add little more 60% say, whatever the total load is coming here, half of that will be taken there, but let us say I am taking 60% of that will one come, that way I am in the conservative side. Then when I am getting this load, then you consider the self weight, and then you add it up and then you design as a column or something like that we can actually do it. So, these all those things you can do it. Now, whenever we go for this one, we take half of this will come and then we can find out, and that way also you can do it. This way we can do it, but this one will be in the conservative side. But if you do go for actual analysis, the load pattern is different, because you will have the different load pattern. Say we are having this type of load, something like that we are having. So, for all those case, whatever the maximum moment, that also you have to find out, and on the basis of that only you can do it. Or if you say that I shall take a concentrated load which is at the support, sorry, at the mid span, then you are in the conservative side. So, what I can say just quickly, so, here you can see the deck, the footpath both sides, and on the basis of that you can calculate. And this is the loading, say 8 ton, 12 ton, 12 ton, 17 ton, 17 ton, and then that one. So, if you go for IRC 100, sorry IRC 6, and from there you can get this loading for 70 loading, then class A loading, how these wheels are actually distributed, that also you can find out. And similarly, we can have class A loading 2.7, 2.7, 11.4, 11.4, then 6.8, 6.8, 6.8, 6.8, like that you can make it. So, on the basis of that actually we do that calculation, and then we can go for manually we can go. Now, the thing that if the total load P, then obviously it will be PL by 4. So, just to give you idea, so this is the one. So, whatever load is coming, say for example, here like this something, for this load if we take it as a say concentrated load here P, and if this is L, so M will be P L by 4, but that one will not be there because it is not concentrated load at one point. So, why shall I go? That means, it is equal to 0.25 P L. If it is say W L square by 8, so then we can say 0.125 W L. So, W is the W into L total load that way. So, you just try to put it in this fashion, then you will find out it is very easy to do it. So, I think that that as per requirement all those things, I think I have answered the questions. Let me see whether any other question is there or not. So, then otherwise we can conclude. So, that obviously there are so many other softwares also there, that way also do it, but at the same time that you can write your own program. So, next question is where can I learn manual analysis? So, manual analysis, if you really want that, you find out old books where you can get it, or you just think actually what best way you can, the values whatever you are getting actually in the software STAD or anything, whether the values are coming all right or not, sometimes you have to do it manually, at least within say 5% or 8% actually we should come with the error of actual result. Okay, then I think we have completed that, and with this I conclude the session. Thank you very much. Best of luck for the exam.